In our third example here, the only information that we're going to be given is that a line passes through two given points. Now, what we need to look out for immediately is, are these given points intercepts? Is either one of them the y-intercept? Is either one of them the x-intercept? Or are they just two random points given to us? Now, if they give us intercepts, that gives us a little bit more leeway as into what approach we could take. But in this particular example, you can see that the two given points are just two random points that are on the line, neither one of them being intercepts. So what we're eventually going to do is we're going to go back and use that point slope form where we have the slope and 1 point to fill in the equation of the line. Before we get to that, however, we have to draw back on prior experience on finding slope. And so since I've been given 2 points, I'm going to go back and use the slope formula that we learned in a previous lesson to find the slope. And you can see here in example 3 that after I finish doing that, I get a slope equal to 1. Now, whenever we choose to plug into the point slope form, what you're going to notice here is that there's really only room for one given point. And so you can see right here we have a y1 and an x1, and of course we have the slope. So I have 2 points and I only have place for 1 point. What you're going to notice is that you can use either of the 2 points. And if you wanted to experiment with this, you could try to write the equation with either point and see if they come out to be the same. And they absolutely should come out to be the same every single time. So now, in this particular case, I chose the -2, -1, and I did that intentionally in this example so that you could see what happens whenever we plug in a negative number into the point slope form. And what you're going to see is we're going to have y minus a -1. And notice how I use parentheses to hold that -1. And then in the other side of it, we have the slope of 1 times x minus a -2. And again, I've used a -2 with parentheses. And then, of course, negative of a negative is just a positive, and I can just rewrite this as y plus 1 equals x plus 2. Subtract 1 from both sides, and then we have a nice simple equation in slope-intercept form. So this is not too much more difficult than what we've done previously. It just adds another step, and that step is to find the slope before we plug it into the point slope form. So let's take a look at an example. Sample problem number 3. Just go ahead and pause the video and work that particular problem on your own. So first things first, I recognize that I'm not dealing with an intercept anywhere. So I'm going to have to find the slope first. So I'm going to go ahead and fill in the slope equation. So I'm going to do y minus another y, and then x minus my other x. And I have to keep it in the correct order from points. So it's going to give me -5 on top, and that's 3 plus 1, so that's going to give me 4, and so that's going to give me a slope of -5/4. Now I'm going to use the point slope form to plug in to write the equation of my line. Now it does not matter which particular point that I use. Just so happens that I'm going to pick this first point, and for no particular reason, to be honest with you. If you do, however, have 2 points and one of them looks like it has smaller or easier numbers, or maybe you like dealing with positive numbers, pick the one that you think would be an easier one to use for yourself. So I'm going to start off with the 3 for y, so that's y minus 3 equals the slope, -5/4 times x minus, in this case it's a -1, so I'm going to put that in parentheses. And so I'm going to just start, and I'm just going to take this one step at a time. I'm going to go ahead and change that negative of a negative to a positive value. Next, I'm going to distribute the -5/4, so -5/4 times x is -5/4 x. And -5/4 times 1 is just going to be -5/4. Now I have to add 3 to both sides, and this is where remembering your fraction rules are very important. So I'll go ahead and we're going to say plus 3, because that's what we did. We added 3 to both sides. Now I can't add -5/4 plus 3 without changing it to a common denominator first. And so the final version of this equation is -5/4 x plus 7/4, and that's our final equation in slope-intercept form. Okay, so you can see here just one additional step of solving for the slope on your own before you can use the point slope form. For our final video in this lesson, we're going to go into a topic that tends to give students trouble from time to time, and that's writing equations for parallel and perpendicular lines. Now, this tends to be a very popular question type for standardized test makers. They want to know that you can make that connection between parallel and perpendicular slopes and then put that value into a line. So in previous examples, we've shown that you either are given the slope, you have to find the slope off a graph, or you have to calculate the slope yourself, and then take that slope in a given point and plug it into the point slope form and come up with the equation. So this is going to be no different, except the type of information they're going to give you is they're going to give you a slope, and then you're going to have to find the slope of either a perpendicular line or a parallel line before you plug it into the equation. So you can see here in example 4, they give us two parts. We have an A part and a B part. And so they want us to find the equation of a line perpendicular and then the equation of a line parallel to y equals negative 3x plus 2. And so the first thing we have to immediately figure out is what is the slope that we're making comparisons to. And so we can see that this slope is m equals negative 3. And so in our first given equation, we're doing perpendicular, and so we have to find the opposite reciprocal or the negative reciprocal slope, and then the given point of 3, 2. Now we also have to recognize that that given point is not a y-intercept or an x-intercept, and so then we would just simply use our point slope form as we've done in the previous examples, and you can see that our final equation is y equals 1/3 x plus 1. Now, in part B, they make it a little bit easier for us, and they simply ask us to find the equation of line parallel. And so since parallel lines have same slopes, we're just going to use the negative 3 again. And so in this case, you can see that we've simplified this down to slope-intercept form, and we're done. So sample problem 4 is going to have you work similar problems. Part A asks for a perpendicular line, and part B asks for a parallel line. So go ahead and pause the video and take some time to do that now. Okay, and so we'll start by just identifying the slope, and so we can see here the slope of the line that we're dealing with is 2, and so if we want to find the slope of a perpendicular line, we're going to use the opposite and then the reciprocal, which is 1/2. And so now when I go to write this, I notice that I have a 0 here. Now this time the 0 is actually in the y space, the y coordinate space, and so this is actually implying to us that this is an x-intercept. Now, if it were a y-intercept, this would be very convenient because we'd be able to just plug this into the slope-intercept form. But since this is an x-intercept, we're not able to do that. And so be careful not to fall for that little trick right there. So we're still going to approach this the same way we would with any other one. We're going to actually plug in values to our point slope form, and so you can remember our point slope form looks like this. And so we're going to plug the point 2, 0 in, so that's y minus 0 equals our slope, which is negative 1/2, and then x minus 2. Now this is really kind of convenient because I don't have to do anything with the 0. I can just use y, and then I'm going to distribute the negative 1/2. So negative 1/2 times x, and then negative 1/2 times negative 2 is going to give me a positive 1, and that is our final equation in slope-intercept form. Our last particular question has us finding the slope, or excuse me, the equation of a line that is parallel to this line. So if the slope is equal to 2, then our second slope is also going to equal to 2. So I'm also going to use the point 2, 0 for this particular equation. And so we're going to say y minus 0 equals 2 times x minus 2. And then I just have to simply simplify this, and that's a very straightforward, simple problem. Alright, so now you've had a little bit of experience writing equations of lines given perpendicular and parallel.